All right, we're going to finish off the video introducing the idea of fractional exponents. So exponents that are fractions, and we're going to use what we already know about exponents and different roots and stuff, and we're going to see if we can relate this fractional exponents to what we already know. So we're going to do that through some examples. So our first example is the square root of 2 squared. And we could work this out, and we do 2 squared and we get to 4, and then we'd square root 4 and get back to 2. But some of you, maybe you're clever and you notice that immediately that this square root is basically canceling or is reversing the square, right? And that's the way I think of it too. If you square something and then you take the square root, you're basically getting right back to where you started, right? You're taking a step forward and then a step back right where you started. So this ends up being 2, as we've already seen. This ends up being 2. And 2 is just 2 to the first power. So what if we think about this square root as in terms of exponents? What is going on here? We're taking this 2 squared, and we're taking this 2 squared, and we're doing something to this that's bringing that 2 down to a 1, right? So couldn't we say that this square root were really just, it can be represented as a 1/2 power? Because when we multiply 2 times 1/2, that gets us back down to the 1, right? And if you're not convinced, let's do one more example, and let's really see how this works. So same idea. You cube something, and then you take the cube root. You get right back to that something that you started with. So this is simply 2, which is 2 to the first power, right? Same thing. And now you probably can already see what's going to happen here. We have 2 cubed, and we're doing something to this 2 cubed that's bringing this cubed back down to a 1. So we can rewrite cube root as 1/3. So in general, whatever number is in here, and with square roots, there's always an invisible 2 here. It's an invisible 2. Will my pen right? There we go. It's an invisible 2. So whatever number is in here, as we can see, is what ends up in the denominator in our fraction, and we can rewrite it, and that is a general pattern. So what would it be if we took the 5th root of just some number x? How could we rewrite this in terms of a exponent? We could rewrite this as x to the 1/5 power, right? Whatever number is here, it goes in the denominator, right? So let's look at a couple more examples. Let's see, we have 4 cubed, and we have all that 4 cubed is being square rooted. So how can we rewrite this based on what we've seen? So 4 cubed, and we're taking that to the 1/2 power, right? Based on what we've just learned, there's an invisible 2 here. We can write the 2 in the denominator here. And now what can we do? We can multiply through. We can multiply this through equals. We can multiply this through, and we're left with 4 to the 3/2 power, right? 3/2 power. But now we can do one more step. We can actually separate it, right? Because look what's happening here. We're doing multiplication. 3 times 1/2. But isn't 1/2 times 3 the same thing? Multiplication, the order doesn't matter. So couldn't I rewrite this as 4 to the 1/2 power, all raised to the 3rd power? Wouldn't it be the same thing? If you multiply this through, I'd get back to here. All 4 of these are still equivalent. And what is 4 to the 1/2 power? That's square root. We've already talked about what that is, right? We've already figured out that 1/2 power is square root. And so now what have we done? We've manipulated this. We've manipulated this problem that had square roots and exponents and stuff, and we can manipulate it to look like many different things. And that's exactly what these fractional exponent laws allow us to do, is manipulate numbers and exponents and roots and all this stuff in order to either better solve them or better simplify or whatever the case is. And we'll see some examples. But look what happened here. In general terms, I can swap these. And this is actually what the formula is. What the general formula is this. And then it's this is one part, and this is one part. And all it says is that you can go from here, and this equals this equals this. So this is basically the general formula if you just replace 4 with x and you replace these with m and n. But we'll rewrite that at the end. But we need to see how this works. And now if we fully solve this, we can get square root of 4 is just 2. 2 times 2 times 2. That gives us 8. And we can solve this at any step. What if we did 4 cubed? That's 64. and then the square root of 64 is 8. So we could have solved this at any step, but we're going to look at this example. We're going to see that in a lot of cases you need to manipulate it in order to solve it, right? In this case, I don't want to use a calculator. Let's say you don't have any calculator and you have to solve this. So you're going to multiply 32 out 4 times. That's pretty tedious, right? And that's why we're given these rules, again, is so we can make things simpler, we can make things easier, we can manipulate it. It's really beautiful once you get into it, once you start to learn it and understand it and get comfortable with it. All right, let's raise this whole thing to the 1/5 power. Because these are equivalent, we've already learned that. The number out here is what goes in the denominator. And this equals 32. If we just multiply through to the 4/5, we're just multiplying through to the 4/5. Now what if we separate it? And we could have gone straight from this step to this step because we've already seen how this works. We could have said, oh, multiplication, the order doesn't matter. I'm just going to swap these. That's perfectly okay. Right? So this equals 32 to the 1/5 raised to the 4th. And 1/5 is just 5th root, right? So I have 32. I have the 5th root of 32. And that's being raised to the 4th power. So see how we've manipulated this to look like 4 different things? And this, we've really used this to our advantage because look what I have here now. I have something I can solve. I think I can find the 5th root of 32, right? Let's see if we can find it. 2 times 2 is 4, times 2 is 8, 16, 32. 2 to the 5th power. 2 to the 5th power is 32. So the 5th root of 32 is 2. So this is 2 to the 4th power, which equals 2 times 2 is 4, 8, 16, right? And see how we've taken something where we would have had to multiply 32 out 4 times and then somehow find a number to multiply by itself 5 times to get that number, right? It's very tedious, and we can manipulate it and use these laws to bring it to look like something where we can solve it without too much trouble, right? And so that's kind of, and we'll do more examples in the next video, but that's kind of the idea of fractional exponents, is you're manipulating these fractions and you're manipulating the roots and what's in the exponent and all these things so that you can better solve and better simplify and do all this stuff. So we'll go ahead and put up now the general formula. You can write it down for your formula sheet or wherever you want to put it. But yeah, hopefully this helped and you have now a general understanding of how to rewrite square root of x as x to the 1/2 and how to go from roots and exponents to fractional exponents and vice versa. And we'll do more examples. Stay tuned for the next video. Okay, so this is the general form. Again, thank you for watching. I hope this video helped. Leave questions, comments, stuff like that below. Hit subscribe if you enjoyed the video. Hit the like button and all that stuff. Go to my channel. I have a whole playlist on algebra, and you can check all that stuff out if you need more help. And I'll see you in the next video. Until then, keep making those brain gains. Keep flexing those brain muscles. Thanks for watching.